Hi guys, this is video number 2 of how you're going to use those factoring patterns to actually solve polynomials. So we went through these factoring patterns in that last video, so if you haven't watched it, make sure you go back and watch this so you know how to factor each of these. And then what we're going to do is we're going to take this and we're going to solve. So this really does take a jump up, and I'm going to walk through these with you guys, and hopefully you guys are going to watch and take notes and learn how to do these, and then you're going to do some practice on it. So we're going to just go through these examples down here, and then you guys are just going to go practice. Okay, so this one I can tell is going to be a difference of cubes because I can do the cube root of each of these numbers and there's a minus sign in the middle. So we're gonna just start this by doing the difference of cubes factoring. So what that is we do the cube root of each of these things. And so then this becomes, let's see, the cube root of x cubed we said was x, and the cube root of 8 is 2. So then we can factor this using the patterns above into x minus 2. Since that's a minus, this has to be a minus. Then x squared plus 2 times x, so 2x, plus 2 squared, which in this case is going to be plus 4. And then what we're trying to solve is when this equation is equal to 0. So at this point, we can solve this. I can set this equal to 0 and solve, and I can set this one equal to 0 and solve. But the thing is it doesn't factor anymore because we can't factor this, or else we would have been able to do it in the first step. So we have to use the quadratic formula. So let's just start with this first one. Let's start with the easy. So if I take x minus 2, set it equal to 0, I can add 2 to both sides, and I can get x equals 2. So one of my solutions is going to be x equals 2. Next thing you're going to do is you're going to take this equation and set it equal to 0 and solve. Now it doesn't factor, so we have to use the quadratic formula. So let's just remember what that is. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you guys are going to be using that a lot, so just make sure you know how to do it. So for this problem, our a is going to be 1, our b is going to be 2, and our c is going to be 4. So let's go ahead and just plug that in. So we get x equals negative b, so negative 2, plus or minus the square root of 2 squared minus 4ac all over 2 times a. Okay, and then what we do is we start breaking this down. So I can't change this negative 2, so this stays negative 2. Plus or minus, now I'm going to do 2 squared, that becomes 4, so I have square root of 4 minus, because this is, let's see, negative 4 times 1 times 4. So negative 4 times 1 is negative 4, times positive 4 is going to be a negative 16, over 2 times 1, which is just 2. And then if I do 4 minus 16, this becomes negative 2 plus or minus the square root of 12, or negative 12 actually, over 2. Okay, so now what you guys have to do is you have to break up this square root. So you have to break up the square root of negative 12. And I did kind of go through this in a video last week, but you're going to break this into perfect squares. So first I'm going to break it into negative 1. And then I know that 12 is the same thing as 4 times 3. And I'm going to break it that way because I know I can do the square root of 4. So then the facts you just have to remember that the square root of negative 1 is I, and that the square root of 4 is 2. So that means this will simplify to be 2i, and then I can't do the square root of 3, so that stays square root of 3. Square root of 4 becomes 2, it comes outside. Square root of negative 1 is I, it goes outside, and then the square root of 3 stays in there. So then we're just going to replace this with the square root right here. So it becomes negative 2 plus or minus 2i square root of 3, all divided by 2. Now I can take this 2 in the denominator and divide it into each of the pieces that are broken up by the plus or minus. So if I do negative 2 divided by 2, this becomes negative 1 plus or minus. And then if I do 2i divided by 2, that becomes I. And then you still have the square root of 3. So then my other two answers are going to be that x equals these two things. And then you guys are just going to write them as coordinate points. So the first one, the really easy one we have over here is we had x was 2. So one of my answers is going to be 2, 0. And then you just have to take these other complex solutions I got over here and break them into the two parts that you have. So you have negative 1 plus I squared roots of 3, and you have negative 1 minus I squared roots of 3. So one of my answers is going to be negative 1 plus I squared roots of 3, 0. And then negative 1 minus I squared roots of 3, 0. And the reason we're writing it like this is because you're solved for x. So these are all x's when y is 0. So your y value should all be 0. And then we're going to say these are our final solutions. Okay, so I hope that makes sense. Let's keep going. Okay, so this one we didn't do factoring patterns because this is very similar to the way that we factor in the past. So if I have this pattern that looks like something to the fourth plus something squared plus a number without an exponent, I can factor this like normal. Okay, so let's factor like normal. So let's see. What multiplies to 2 and then adds to 3? Well, that's definitely 2 and 1 because 2 times 1 becomes 2, and then 2 plus 1 becomes 3. And now since this is an x to the fourth, all that changes is I need the first part of my parentheses to be an x squared instead of an x. So that if I do x squared times x squared, I get x to the fourth. And then we've got plus 2 plus 1. So then if I were to multiply this out, you do x squared times x squared gives you x to the fourth. X squared times 1 is 1x squared. Plus 2x squared, that gives you your 3x squared, and you add that together, and then 2 times 1 becomes 2. So then that just factors nicely, and now they're both quadratic, so now you just set each of them equal to 0 and solve. So you got x squared plus 2 equals 0, and x squared plus 1 equals 0. Okay, so let's subtract 2. So in this one, you got x squared equals -2. Now to get rid of the squared, you do a square root of both sides. Remember, when you do this, you have to put a plus or minus in front. So then on the left side, this just becomes x. And then you got equals plus or minus the square root of -2. Now we can break this up because we know anytime there's a negative in the square root, we have an imaginary unit because the square root of -1 equals I. So I can break this into plus or minus the square root of -1 times 2. And then when I do the square root of -1, it makes an I come out. So this becomes plus or minus I squared to 2. So those are going to be 2 of my answers right here. Okay, and then let's shift this over. So we've also got x squared plus 1 equals 0. So first thing I'm going to do is I'm going to subtract 1. So you've got x squared equals -1, do the square root. Remember, this has to be plus or minus. So then you'll get x equals plus or minus the square root of -1. And then remember, because of this fact, square root of -1 is I. This just becomes plus or minus I. And then those are my other 2 answers. Now, the one thing we have to try to remember is that the degree tells us our number of solutions. So we did talk about this, I think last week. So since this was a degree 4, because my highest degree was 4, I should have 2 answers. So right here I have 1, 2 because the plus minus, and then I have 3, 4 because the plus or minus. And then if we go back to this first one, this was a degree 3, so you should have 1, 2, 3 solutions to this as well. Okay, and then remember, let's just write these as points because these are all of our x values. So we've got I squared to 2 comma 0 coming from this one. And then I also have -I squared to 2 comma 0. I have I comma 0. I have -I comma 0 coming from this solution right here. So then these are going to be all 4 of my solutions for this problem. And then you're done. So those are the solutions to that polynomial. Okay, so this one is weird because it is x to the 7th. So that means it's gonna have 7 answers, as crazy as that is, and we don't have a way to do this. So I think the first thing here is we have to realize that there's a greatest common factor that can be divided out here. So I think in each of these terms, I can definitely divide a 2 out. And then I also can divide an x cubed out because I can take 3 x's out of both of these. So what that becomes is your 2x cubed goes in front. And then if I do 2x to the 7th divided by 2x cubed, your 2's cancel. X to the 7th divided by x to the 3rd becomes x to the 4th because 7 minus 3 becomes 4. Let's see, -32 divided by 2 becomes -16. And then your x cubed divided by x cubed disappears. So then you have this equals 0 over here. Now, hopefully we recognize that this is going to be our difference of squares because I can do the square root of each of these. So if I do the square root of x to the 4th, that becomes x squared, and then square root of 16 becomes 4. So let's see, we've got 2x cubed out front still. We know this difference of squares factors here, so this x squared goes in front. The 4 goes in back, and then remember 1 is a plus and 1 is a minus, doesn't matter which one. And then this one is really mean because this is again a difference of squares. So you can do square root again and get this to be an x and a 2. So I can factor this into x plus 2 and x minus 2, and then I have these other factors as well. So this one was a loaded one, but now we've got it down to everything that we can solve. So what you're gonna do is you're gonna take each of these factors or each of these terms and set them equal to 0 and solve. So let's start with this first one. So I'm going to take 2x cubed, and I'm going to set it equal to 0 and solve. So the first thing you would do is divide by 2, x cubed equals 0. Now the only way for this to be possible is if x is 0. So one of my solutions is going to be x is 0. Now if we go back to like what exponents mean, this is really giving us 3 solutions because it's doing a wiggle through the graph at 0. So this is going to count for 3 of our answers whenever we're done, just to keep that in mind because there's a 3 exponent here on this x. Okay, so then the next one we're going to solve is we're going to solve this x plus 2. So if I set that equal to 0, you got x plus 2 equals 0. Subtract 2 from both sides, you get x is negative 2 is one of your solutions. And then I'm going to do it again with my x minus 2. So if I set x minus 2 equal to 0, add 2 to both sides, you get x is 2. Okay, and then the last things that we have to solve are this x squared plus 4 equals 0. So first thing you do is subtract 4 from both sides. You got x squared equals negative 4. Then we do a square root to get rid of the squared. Remember when we do this, you put a plus or minus in front. This becomes an x equals plus or minus the square root of negative 4. And then remember, we can do the square root of negative 4. This becomes negative 1 times 4. The square root of negative 1 is I because it's imaginary, and the square root of 4 is 2. So this becomes plus or minus 2i. So we've got 1, 2, 3, 4, 5, 6, 7 because this is cubed. So we've got our 7 total answers. And then remember, we just go write them as points. So we've got 0, 0 based on this solution. We've got negative 2, 0 based on this. We've got 2, 0 because of this guy. And then we've got 2i, 0 and negative 2i, 0 because of this solution. You have 2 of them because you're plus or minus. And then these are going to be your final answers. So then these are just your solutions. Okay, so I know this is a lot, and I hope you guys are following along and doing this so that you can do some good practice. And I hope you're writing this down because this is definitely some of the hardest stuff we've done. Okay, so recognize you've got x to the 4th, x squared, and then nothing with an exponent. So you're just going to factor like normal. Now I can't do this with a trick because there's a number in front of this x to the 4th. So we're going to do this with an x box. And you could do the x box with the other one as well. So let's draw our x box. So we put the x to the 4th, our highest degree in this top box right here. So 4x to the 4th. And then we put the negative 9 diagonal it. We multiply those together. So 4x to the 4th times negative 9 becomes negative 36 x to the 4th. That goes in the top of our x. And then this minus 5x goes in the bottom down here. So then just remember, we're looking for things that multiply to be this and then add to be this. So if we want things that multiply to negative 36, add to negative 5, I think we can use 9 and 4 again. So this is 9 and this is positive 4. And then these have to be x squared so that when I do x squared times x squared, I get x to the 4th. Excuse me, negative 9x squared plus 4x gives us negative 5x. So then I put both of those in the box over here. And then I factor things out. Sorry, let me let my dog in. She's dying. Okay, so then you just factor out your diagonal. So if I look at this one, this can have a 4 and an x squared divide out of both of those, so this becomes 4x squared. If I look at this diagonal, I can take out a negative 9. If I look at this diagonal, let's see, there's no number that divides out of 4 and 9, but I can take an x squared out. And then again, there's nothing that comes out of 4 and 9, so this should just become a 1. Okay, so what we did is we factored that original one into 4x squared minus 9 and x squared plus 1 equals 0. Now we can't do this because that has a plus, but this is a difference of squares. So this is the one where we do the square roots and we factor it a little bit more. So the square root of 4x squared is 2x. The square root of 9 is 3, so this factors into 2x plus 3 and 2x minus 3. And then you still have this one. Okay, so now we've gotten this down to a point where we can solve. So we're just going to set each of these equal to 0 and solve. So I'm going to take the 2x plus 3, set it equal to 0. So first step is to subtract 3. So you've got 2x equals negative 3. Divide by 2. So x equals negative 3/2 is one solution. Then I'm going to take the 2x minus 3, which should be really similar, but we add 3 here first. Then we divide by 2. So x equals 3/2 is the other one. And then I have to take this x squared plus 1 and set it equal to 0. So first thing we do is subtract 1. So you get x squared equals -1. Undo the squared to do a square root. Remember, plus or minus in front. So this becomes x equals plus or minus the square root of -1, which we know the square root of -1 is I. So this is just plus or minus I. And then those are my other 2 solutions. And this was a degree 4. So these should be my 3 answers. So then let's just write them as points. So we've got -3/2 comma 0, +3/2 comma 0, I comma 0, and -I comma 0. So your y is 0 for all of these. So then these are going to be your final solutions when solving this polynomial. All right, guys, one last one, and then I'm going to let you go practice some of these. So this one is, I can see a cube, so it's definitely got to be one of our cubed ones. This is going to be a sum of cubes because this is a positive. So first step we do is we do the cube root of each of these. The cube root of 216x cubed is 6x. Because if you do 6 times 6 times 6, you get 216. And then the cube root of 1 is just 1. All right, so let's factor using that pattern. So this becomes 6x plus 1. This is a plus, so this has to be a plus. Then this becomes your a, which is 6x cubed, or 6x squared, minus these two things multiplied together. So 6x times 1 is just 6x, and then plus 1 squared. Okay, so let's just rewrite it a little bit. So you've got 6x plus 1. If I do 6x squared, 6 times 6 becomes 36, and then x times x becomes x squared, minus 6x plus 1. And then remember, we're solving this for equals 0. So now this is one of the ones where I can set this one equal to 0, so I can do that at this point. So I'm just going to do 6x plus 1 equals 0, subtract 1 from both sides. So 6x equals -1, divide by 6, x equals -1/6. That's one of my solutions. Now this is a degree 3, so I should have 2 more. So I'm going to get my other 2 from solving this. Now we know this doesn't factor anymore because we already factored it using our sum of cubes. So we have to use the quadratic formula. So use quad formula. Okay, so this one we got a is 36, b is -6, and c is 1. So then let's just go plug it into our quadratic formula. So x equals -b, so -6, plus or minus square root of b squared minus 4 times a times c all over 2 times a. So this is getting big because our a is 36. So negative, this becomes +6, plus or minus. If I do -6 squared, -6 times -6 becomes +36. And then if I do -4 times 36, that becomes -144. And then times 1, so -144 over 2 times 36, which is 72. Okay, so then in your calculator, you can do 36 minus 144, and you'll get 6 plus or minus square root. This is -108 over 72. Now, I did do a video on this, but you guys should know how to break this up at this point. So what you're going to do in your calculator, because this one's not as intuitive, is you're going to take 108, and you're going to start dividing by perfect squares. So remember, perfect squares are like 4 because that's 2 times 2, or 9 because that's 3 times 3, 16, 4 times 4, 25, 5 times 5, 36, 49, etc. And you're just going to figure out which one of those divides nicely into 108, meaning there's no decimals when I divide. So one that does work really nice is if I do 108 divided by 36, I get a nice answer in my calculator of 3. So what that means is if I do 36 times 3, I get 108. So I'm going to break this up, and I'm going to make my square root be the square root of -1, because it's a negative, times 36 times 3, because I know if I multiply all 3 of these, I get -108, and I'm going to divide that by 72. Okay, so now what I do is I break each of these up. So the square root of -1 we know is I, so it's going to come outside. And the square root of 36 is 6, so that's going to come outside. So this becomes 6i, and I can't do the square root of 3, so it stays in there. And then you got plus or minus 6 over 72. Now you do want to simplify this more. I think 6 divides nicely into 72. So if I do 72 divided by 6, and I divide each of these parts by 6, so divide by 6, divide by 6, divide by 6, the top becomes 1 plus or minus I squared to 3. And then if I do 72 divided by 6, I get that to be 12. So then my other answer is going to be these two things right here. Okay, so let's write them as points. So the first one we got was the negative 1/6. So I'm going to have negative 1/6 comma 0, one of my solutions. And then I'm going to have 1 plus I squared to 3 over 12 because of this. And we're not doing plus or minus, one's just plus, comma 0. And then you have 1 minus I squared to 3 over 12, comma 0. And then those are going to be your final solutions for solving this polynomial. So I know this is a lot, and I know this is really challenging, which is why I hope you've done all the learning up to this point, because a lot of it is going to build off of each other. So what you guys are going to go do now is you're going to do the 832 part 2 practice, and it's a lot of practice on this, and this is really challenging. So please don't write question marks and things down without getting help and turning it in. Please use office hours. Please send me emails if you need help with stuff. I know this is hard, and I'm here for you. I hope you guys are having a great day, and please reach out if you need my help. Bye, guys.